Hi guys, welcome back to another video. In today's video I'm going to show you how to solve a linear first order differential equation of the form dy over dt equals a times y plus bt, where a is a constant and bt is some expression involving t. So to find all solutions you need to follow these three steps. So the first step, you need to find the general solution to the homogeneous equation dy over dt equals a times y. And you can name this solution y1. Step number 2, find one particular solution to dy over dt equals a times y plus bt. And this can be done by intelligent guessing. And we're gonna talk about how you can guess a particular solution. So you can name this solution as y2. And final step, your general solution to the equation is y equals y1 plus y2. So now let's see how you can come up with a good guess to your particular solution to the equation. And let's go through the rules of thumb of guessing. Depend on the four cases. So the first case, if your bt is an exponential function like e to nt, your guess should be in the form of a times e to nt. Case number 2, if your bt is a trig function like sine of nt, your guess should be in the form of a times sine nt plus b cosine nt. And case number 3, if your bt is a polynomial function, your guess should be in the term of a t squared plus bt plus c. However, if your guess should solve the homogeneous equation dy over dt equals a times y equals 0, then you should multiply your original guess by t and try again. So let's do a few examples here to better understanding these steps and this guessing method. So example number 1, let's solve the equation dy over dt equals 3y minus e 4 to 40. So example number 1, dy over dt equals 3y minus e to 40. So step number 1, we need to solve the homogeneous equation dy over dt equals 3y, and that can be done by separation of method technique. And if you are not familiar with this technique, you can see my last video which I explained this method. So now I'm just gonna go through it, but very quick, not in a deep detail. So I'm gonna divide both sides by 3y, so I'm gonna get 1/3 y dy equals, and multiply both sides by dt, so equals dt. Now integrate both sides. So y should be in the denominator here. So 1 over 3y. So 1/3, and here 1y, 1 over y dy equals dt. And then this is 1/3 ln of y plus constant c1 equals t plus c2. So I'm multiplying both sides by 3 and moving the constant to the right hand side and replace it with c. I get ln of y equals 3t plus capital C. Now if I solve for y, I get y equals e to 3t plus c, which is e to 3t times e to c, which is just a constant, so the solution will be c e 3t. So this is my solution to the homogeneous equation using the separation of variables method. So now my bt, it's in form of exponential function, so e to 40. So my guess will be a times e to 4t. So first my y1, it's my solution to the homogeneous equation, ce 3t. Now let's do, so my guess for y will be a times e to 4t. Now let's find what's that constant a. So dy over dt, it's gonna be 4a times e 4t using the chain rule equals 3y. So 3y is 3 times a, 3a times e to 4t minus e to 4t. Now if I move a's to one side and factor out by e to 4t, so I get 4a minus 3a equals negative a e to 4t. And that leaves me with a equals negative 1. So now my y2 is negative 1 e to 4t. And I'm done now. I have y1 and y2. So the general solution to my equation will be y equals y1 plus y2. So y equals y1 plus y2, which is c times e to 3t minus e to 4t. And that's the general solution to that equation. Now let's try one more example with trig function. So let's solve dy over dt. So second example, dy over dt equals negative 3y plus sine 4t. So step 1, solve the homogeneous equation dy over dt equals negative 3y, and that's similar to what I did in the first example. I'm gonna skip the solution. So you can solve it using the separation of variables technique. So you get y1 equals c times e to negative 3t. So this is my y1. So my bt, it's in the form of sine 4t. So my guess should be in the term of a sine 4t plus b cosine 4t. So I'm guessing A sine 4t plus B cosine of 4t. So now dy over dt plus 3y equals sine of 4t. So differentiate A sine 4t plus B cosine 4t leaves me with 4a cosine of 4t minus 4b sine of 4t plus 3 times y, so that's going to be 3a sine of 4t plus 3b cosine of 4t, that's equal to sine 4t. So if I combine sines together and cosines together, I get here cosine of 4t times 4a plus 3b plus sine of 4t times negative 4b plus 3a equals sine of 4t. So I need to solve for two variables, so I need two equations. So on the right hand side I don't have cosine, so assume it's 0. So the first equation for a plus 3b equals 0, and the second equation is 3a minus 4b equals 0. So this is a linear system equation. You can solve it using your favorite method, but at the end of the day you're just gonna get a equals 3/25 and b equals negative 4/25. So now my y2 equals 3/25 sine of 4t minus 4/25 cosine of 4t. So that's my y2, and the general solution to my equation will be y equals y1 plus y2. So y equals y1 plus y2. y1 is c e to negative 3t plus 3/25 sine of 4t minus 4/25 cosine of 4t, and that's my general solution using the Gaussian method. So now let's find out if your guess can solve the homogeneous equation. So what we should do in this case. So for example, we try to solve the differential equation dy over dt equals negative 2y plus 3 times e to negative 2t. So dy over dt equals negative 2y plus 3 e to negative 2t. So my y1, it's gonna be the solution to my homogeneous equation dy over dt equal negative ty, and you can solve it using separation of variables method, similar to the previous two questions. So it's gonna be c e to negative 2t. Now bt, it's 3 times e to negative 2t. So my guess will be my first guess will be y equals a times e to negative 2t. So what's the derivative of that? Using the chain rule, it's gonna be negative 2a e to negative 2t equals negative 2a, so negative 2 times y, so it's negative 2a to negative 2t plus 3 times e to negative 2t. And you say why it's not a good guess, because I'm gonna get 0 here, so this and this cancel each other, so I'm gonna end up with 0 equal 3 e to negative 2, so not a good guess, not a good guess. So now I need to multiply my origin guess by t and try again, following the rules. So multiply my origin guess by t, so my guess will be y equals at e to negative 2t, and the same thing here, dy over dt plus 2y equals 3 times e to negative 2t. So using the chain rule or the product rule here, so it's gonna be, because I have two functions, t and another function e to negative 2t, so I'm gonna use the product rule. So the product rule, it's gonna be the derivative of t, which is 1, times the second function, so a times 1 times e to negative 2t plus the derivative of the second function, which is negative 2 e to negative 2t, so minus 2a t e to negative 2t equals 3 times e to negative 2t. So now you can solve for a. So now I have this guy here, a to e to negative 2t. It should be equals to this guy here, because I don't have the term t in each one of them, or in any one of them, so that leaves me with a must be 3. So now my y2, it's 3t e to negative 2t, and my general solution, it's the same thing, y equals y1 plus y2, so y equals y1 plus y2, which is c e to negative 2t plus 3t times e to negative 2t. So this is my general solution to that equation. using the guessing technique. So I hope you find this video very helpful. I will put here and continue next time. Thanks for watching.